All right, so Algebra 1, the last lesson of Chapter 7, is 7.6, where you're still solving systems, but they're linear inequalities. And really the only way we have to solve a linear inequality for the time being is a graph, okay? So in order to graph a linear inequality, remember, you first graph the corresponding equation, okay? And then it's a solid line if the inequality is less than or equal to or greater than or equal to. And it's a dashed line for just less than or just greater than, okay? And then you have to shade the half of the plane that contains your solutions. And you did that using a test point, okay? Remember that. So you can have a system of linear inequalities just like a system of linear equations. And it looks just like a system of equations, okay? Except now they're written as an inequality instead. And so then a solution is going to be an ordered pair that satisfies both. Okay? And the graph is all of those solutions. So in order to graph a system of linear inequalities, you're going to graph them all on the same coordinate plane. And then you're going to look for where the shading overlaps. Okay? Right? So we graphed linear equations in a system, and we ended up with a graph looking like this. And we said, okay, this was our solution right here, where they intersected. Now that they're inequalities, these are going to have shading to them. So suppose this one is shaded down here, right? And this one shades this way. Okay, so then the solution is where they overlap. So it's this shading here. Okay, so let's see how we do that with an example. So we have this system, x is less than 4, y is greater than or equal to -3, and x minus y is greater than or equal to 4. Okay? So we are looking to graph this, okay? Here's our grid. So we're going to graph each one in the same coordinate plane here, or the same xy axis, okay? So I'm going to draw here's my x-axis. And my y-axis. Okay, make that a little darker here. All right, and we're gonna go, here's 1, 2, 3. Okay, actually it should be here. All right, so I'm going to graph y, or not y, this one first. I'm going to graph the corresponding equation, x equals 4. Okay, so here's 1, 2, 3, 4. It's a vertical line and it's going to be dotted because it's just less than. Okay, so And then I want all x values less than 4. So that's going to be here. I suggest using different colors, okay? It's going to make it easier to see where they overlap. So we're going to say it's in here. Okay, that's the first one. The second one I'm going to graph is the corresponding equation y equals -3. So 1, 2, 3. It's a horizontal line at y equals 3, and it's going to be solid because its y is greater than or equal to 3. Okay, y values greater than are up this way. So again, I'm looking for the overlap, so I'm just going to stop right here for now. And then last, I am going to graph this one. So I'm going to graph the corresponding equation, x minus y equals 4. Okay, so to graph this, right, you let x equals 0, you get negative y equals 4, so you get y equals -4 right here, and then you're going to let y equals 0 and get x equals 4 here. Okay, then you need to connect those with a straight line. Okay, but it's going to be solid because it is greater than or equal to, so I connect these two with a solid line. Okay, and then you have to decide which way this one shades. Is it going to shade up, above it, or below it? Okay, so I'm going to test, say 0, 0. Okay, that's right here. So is 0 minus 0 greater than or equal to 4? And it's not, so I'm going to shade below, okay? You are looking for where they overlap, though. So if I look at all the shading, right, I've shaded up this way. The overlap is in this little triangle area. Okay, so that's my solution shaded in there, because that's where they all overlap. Okay? All right, let's graph one more, and then I'm going to show you how to write, be given a graph and to write the system that goes with it. So you're graphing each one independently but on the same plane and looking for where the shading overlaps. So we're going to graph x is greater than or equal to 1, x is less than or equal to 4, y is greater than or equal to -1, and y is less than or equal to 1/2 x plus 1. Okay? Again, there's our coordinate plane. We're going to draw our x and our y axis. It's our y axis. Here is our x axis, and I'm going to draw my scale. So 1, okay, then we're going to graph corresponding equations, right? So we're going to graph x equals 1, which is here, okay? So it's a vertical line, and it's going to be solid because it's the equal to. So I'm going to put a solid line at x equals 1. Okay, x values greater than 1 are this way, so shaded. Okay? Then you're going to graph this one. You're going to graph the corresponding line, x equals 4. So it's here. Okay, again, a solid line because it's equal to. Then you're looking for x values less than 4, so it's this way. But again, it's only overlap, so I'm not going to go past the first line because I just want that overlapping area. Okay. Then we're going to graph y equals -1 because that's the corresponding equation there. So y equals -1 is here. Again, it's going to be solid because it's greater than or equal to. So solid line. Okay. Y values greater than -1 are this way, but again overlap, so you're just in this section. And then the last one is y equals 1/2 x plus 1. This is in slope-intercept form, so we're going to graph. The intercept is +1, slope is 1/2. So there's up 1 over 2, or down 1/2. Okay, again, this will be a solid line because it's greater than or equal to. And we just have to decide if we're going to shade above it or below it. So let's test 0, 0, which would be below the line. So is 0 less than 1/2 times 0 plus 1? And it is, so that means you shade below, but you're looking for overlap. So it's in here. Okay, so what your graph is really, or where your solutions are, is this line to here, to this one here. So it's completely bound in that figure, and then anything in between those lines. Okay, so that's graphing them. The secondary part to this would be to be given a graph and asked to write the system that defines the graph. So I'm going to show it to you. Okay. I'm just drawing it, and then I will show you the system we're going to graph. Okay. So this is the graph we are given. We would like to write the system that goes along with it. Okay? So in order to do this, you have to write the equation of each line. So we're going to start with this top one, the dotted one. Okay? So we know that it's going to be less than or greater than because it's dashed. So if we look, we can see the y-intercept is here at 1, and then the slope is up 1 over 1. Rise over run, so slope is 1. So it tells us y, and then we'll decide, is x plus 1. We have to decide if it's greater than or if it's less than. We want 0 compared to 1 to be true because it's shaded below. Because 0, 0 is part of that solution. So 0 is less than 1. So that's our first line, right? For this top one, y is less than x plus 1. For the second one, we're going to do the same thing. It's solid. So it's going to be less than or equal to or greater than or equal to. Okay, we can see the intercept is at -2 with a slope of rise of 1 over 1. So a slope of 1. So y is x minus 2. We want 0 to make it a true statement because it's in the solution. So 0 is greater than or equal to x minus 2. For this second line. Okay, so that would be your system, would be y is less than x plus 1 and y is greater than or equal to x minus 2. For the system that is shown there. Okay, so in 7.6 there are inequalities, so you're shading and then writing the equations.